All right, welcome to Math 0106. This is lesson 21. We are talking today about solving percent problems in applications. So this is going to be an exercise of translation for the first one at least. So it says literally translate to a percent equation, then solve. What is 11% of 49? Now we talked previously, we know the word what means X. We know the word is means equal. 11% is 11 over 100. Of means to multiply, and 49 is 49. So what we're doing here is we're taking it word for word, and we're translating it into math. And so now we're just going to solve. It's 49 over 1. I'm actually going to multiply across, so we're going to do 49 times 11. 94094. This is going to give me 539. So this gives me 539 over 100 equals X. And I wanted to leave the 0, the 100 on the bottom there because this just tells me I jumped 2 places. So X is 5.39. And there's my answer. So 11% of 49 is 5.39. Think about it. That makes sense because 10% of 50 would be 5. So 11% of 49 means it's going to be close to 5. And so that makes sense. And that's the other thing I would encourage you to do as you solve these problems is ask yourself, does my answer kind of correlate to what makes sense? Okay, let's look at number 2. Jennifer invests $1,000 at 7% simple interest. How much is in her account after 2 years? So let me put this down here. So if she gets, if she has $10,000 and she invests 7% at simple interest, how much is the account after 2 years? Okay, now this is something that's very, very, very important. I don't see this too frequently on like final exams and tests, but it is something that you will see in future classes, which is if you have something increasing by, in this case, 7%, what you have is originally 100% of the value, and it's increasing by 7%, which means you now have 107% of the value. So this would be 10,000 times 1.07. Now, the next bit that's important to realize is that we're doing this how many times? We're doing this 2 times, right? So we'd have to multiply by another 1.07. Well, what happens when you multiply something by itself? Well, this is the same thing as saying 1.07 squared. 10,000 is still the same. And so this is actually the simple interest formula. This is where it actually comes from. We sometimes see it written as P equals A1 plus R to the T, where T is time. So A represents the initial amount. R represents the rate, and T is the time period. And as you progress in courses, you will find yourself getting to a point that this formula will morph into something else. But in this format, what we're really doing is this is 10,000. This is 1 plus the rate, which is 7%. So 7 over 100, which is 0.07, and we're going to do it for two years. And this becomes 10,000, 1 plus 0.07 squared, which is 10,000, times 1.07 squared, which is what we got right here, right? And that is that's going to be your answer. So what I hope is that in seeing the formulation of this, what you see is that you understand where these formulas come from. Because if you just memorize a formula and spit back into it, what's going to happen is once you walk away from this, 3 months from now, 1 month from now, maybe 1 week from now, you're going to forget it. So it's not really worth your time. But if you understand where it's coming from, you can always formulate it, or you can kind of recreate the formula on the fly. And so it's just permanently ingrained in your head. So in any case, I'm not too concerned with what this is equal to. we can multiply 1.07 times 1.07 and multiply by 10,000. But I'm just going to tell you what the answer is. So the answer comes out to be 11,449. You can work this out for yourself. You guys know how to do this. I'm not going to concern myself with the math to solving this. I'm more concerned with the setup than actually solving. Okay, let's move on to number 3. And actually, let me just do number 3 on another page. So here's number 3. Find the better buy lowest cost per ounce by finding the unit price rounded to 3 decimal places if necessary. So shampoo at $6.72 for 12 ounces and $9.90 for 18 ounces. And this is actually something that, I don't know about y'all, but I do this all the time when I'm at the grocery store. I sit there and try to figure out what's actually the cheaper version of it, right? So what it's asking us to do is essentially to reduce these. What you can see here is that the exercise that we're engaged in right now is to really, this is almost like a review. We're putting all the skills we've learned this semester into one sort of word problem situation and trying to solve. So it's a good review for everything, and hopefully if you've been watching all these videos, this is not too bad. So we're going to reduce, it says per ounce, so I'm just going to divide this by 12. I'm going to have to figure out what 6.72 is when I divide by 12. So how many times does 12 go into 67? I don't know, so I'm just going to keep adding 12. Just keep adding 12. Just keep adding 12. And we're going to 67, so now I've gone bust. So let's see here. So we've added 12. 1, 2, 3, 4, 5. We went bust at 6. So we've done this 5 times. So this goes in 5 times. This is going to give me 60. And this becomes 72. We know 72 is 6 from here. This is why I like this method. So we end up getting 0.56. So this means it cost 56 cents per 1 ounce, right? Cost 56 cents per 1 ounce. And we're going to do the same thing on the other side. So we're going to do literally the same exact process. I'm going to divide 18 by 9.90. When I do this, remember the number on top goes inside, the number on the bottom goes on the outside. Person on the horse, person goes inside the house, horse goes on the outside. How many times does 18 go into 990? Actually, you know what? Let me do this on another page. So I have 9.90 divided by 18. I said that this is 18 into 9.90. So I'm going to keep adding 18 until I get to a number at 99 or above. So this is 8 plus 8 is 16. Carry the 1. This is 36. Plus 18 is 14, 4, 5, 54, plus 18 is 12, 6, 72, plus 18 is 10, 8, 90, and I know that the next one's going to go over, but that's okay. So how many do I have here? Here we have 1, 2, 3, 4, 5, 6. So it goes in 6 times. I'm sorry, 5 times, because it's 6 you go over. So this is still 5. And that's 90. This gives me 90. And we subtract and we get another 90. So we're seeing that we're going to get 0.55555 repeating, right? Because we're going to have 18 into 90. Well, let's see here. 1 second. Sorry. 18 into 90. I lied. Not 0.55. 18 goes directly into... 18 goes into 95 times. I'm stumbling with my words here. So this is just 0.55. So this is going to be... Let me do a different color. This is 0.55 in 1 ounce. So I think the question said which is cheaper. That makes more sense. Which is better buy, so which is lowest cost per ounce, cheaper, and it's the bottom one, which typically tends to be the case, right? If you buy more of my product, I'm going to give it to you for cheaper. Though that's not always the case, so you always got to check. So this is a good life skill right here. Okay, let's look at number 4. And actually, I'm just going to do number 4 on another page. So let's look at number 4. A bag of fertilizer covers 2,000 square feet of lawn. Find how many bags of fertilizer would be purchased to cover a rectangular lawn 110 feet by 140 feet. Okay. So anytime you're asked to figure out how much of one thing goes into something else, that is a fancy way of saying division. So what you need to do, though, is you have a lawn that's not drawn the scale, 110 by 140. So we have to first multiply 140 by 110 and see what we end up getting. So if we add these together, we get 4, 5, 1 with 2 zeros. So we end up getting 15,400. So with 15,400, we are asking you how many 2,000s go into that. Right? So like think of it as 2,000 is 2 by, think if you have a bunch of like little 2 by 1,000 pieces of dirt, how many of these can I slide into here? That's essentially what we're trying to do. Though the dimensions here wouldn't make sense because 1,000 would be way off to the side. But we're trying to figure out how many of those can go inside that rectangle. So let's solve this. Well, the first thing we always want to do is we can slice out zeros. So we're really just doing how many 20s go into 154. Now look, let's just use some common sense. We know 14 divided by 2 is 20. So we know this is 14 point something. Okay. Which means if the question is asking us how many bags of fertilizer should be purchased, right? If it's 14 and something, the answer to this is going to be 15. And the reason why I have to say 15, I'm sorry, I said 14 and something. I meant to say 7 and something, right? Because 7 times 2 is 14, right? So it's 7 point something. Just to be clear here, I'm rounding this down to 140 and saying, look, if I simplify this, I get 7. Okay, so if we know 14 divided by 2 is 7, and we know 16, or 160 divided by 20 is 8, then 154 has to live between 7 and 8. So what I'm doing here is I'm trying to be efficient with my time here. Now the question is, so we have 7 point something. I don't know what the something is, but I don't need to know what the something is here. The question that I have to answer is, how many bags do I need? Well, 7 and some change will fill it out completely. I can't buy a fraction of a bag, so I need 8 bags total. I need more. I'm going to have some leftovers, in other words. It's the only way it's going to work out. So that's an efficient way of doing this. If you wanted to, you could divide 154 by 20 and calculate exactly what it would be. So this would be 7 point something. We know this because like I said, it goes in 140 times. And 20 goes into 147 times, so it's just 7.7. And that would be the exact number if you wanted it to have it exact. But it's not necessary. And efficiency is, I encourage efficiency, not just for the sake of making the problem easier, but because efficiency means the propensity towards silly mistakes drops dramatically. So keep that in mind. Let's go on to the next one. So number 5, it says a firefighter needs to estimate the height of a burning building. She estimates the length of her shadow to be 8 feet long and the length of the building shadow to be 72 feet long. Find the height of the building if the firefighter is 5 1/3 feet tall. Okay, so what is going on here is, and this is actually, without exposure to this, is actually pretty difficult to notice. What it's saying is, she estimates the length of her shadow to be 8 feet long. So her shadow, that she's right here, she's this length here. This is the firefighter. And the length of the shadow of the fire to be 72. Find the height of the building if she is 5 1/3 feet tall. Okay, so what we're doing really, this is kind of a condensed picture of it, but what we're really saying here is, if I draw them as separate, this is 8 and this is 5 1/3, and the next one is, it's an ugly looking triangle. That's even worse. Okay. The next one is 72, and this is x. So what we're trying to do is create a proportion, right? So we can say 8 to 5 1/3 is, you know what, let me color code it. Editing on the fly. 8 to 5 1/3. Notice what I'm doing here. I'm doing shadow to height, and you want to make sure your dimensions are clear here, right? And we're comparing this to shadow, which is 72, to height, which is x. And I'm going to be honest, I wanted to say x over 72 for the second one when I initially was writing it, but then I noticed that I had written shadow to height, and that makes, so I knew I had to put 72 on the top. So you could cross multiply if you want to. I believe 14 times 8, no, that's too much. What am I doing? 9 times 8. I've been doing too much math is what's going on here. 9 times 8 is 72. That should be known. I apologize. So times 9, so all I have to do is multiply this one by 9, and that'll give me the answer. So what you want to do with 5 1/3 is you want to convert it into an improper fraction. So 3 times 5 is 15 plus 1. Remember, this is the Texas method. You multiply. So 3 times 5 is 15. Then you add 1. So 16 over 3. And we're going to multiply this by 9, right? And this should be an easy exercise because 3 goes into 9 3 times. 16 times 3 is 48. And there's our answer. So, again, what we're seeing, this is pretty much just a review. The setup here is the tricky part. I'll be honest, you're probably not going to see something like this on an exam. But this is stuff that you would see, and if you're going into more advanced math courses, particularly if you're seeing triangles, so think trig. So if you're going off into that field, you have to take trig courses. This is stuff that you're going to see in those classes. Not too much in a college algebra-based course or in a statistics course. Okay, let's move on to number 6. In a survey of 100 people, 4 preferred relish on their hot dogs. What percent preferred relish? Okay, so we have 4. Well, look, let's not beat around the bush here. We're out of 400. You're choosing 4 out of 400 out of 100, right? So percents are out of 100. So this is just 4%, right? This is literally 4 out of 100. We don't need to write all that. It's just 4%. Okay, let's move on to the next one. Basketball player made 30 out of 100 attempted free throws. Not a very good basketball player. What percent free throws was made? Okay, again, this is out of 100, so we know that this is going to be 30%. Let's not waste our time on that. Okay, on to the next one. 71 is 0.71%. So what I'm going to do is I'm going to write 0.71% is out of 100. So I just put 0.71 out of 100. It's not 0.71. 0.71 out of 100, so this is actually a very small number. Of means to multiply what? We said what is x. Okay. Now here we have a little bit of an issue here in the sense that I do have to show you a little bit of algebra. What we want to do here is get rid of 0.71 over 100. So the way we do that is we multiply by the reciprocal, because these would divide out and these would divide out. If you do this by one side, you have to do it on the other. So this leaves me with 100 over 0.71 times 71. And this is going to be equal to x. Okay. Now all we got to do is clean this up. And so what I'm going to do here is I'm going to rewrite this as a complex fraction. This is 71 over 100. And what we know is from the previous videos, we can just pop this to the top. So this is going to be 1, 2, 3, 4 over 71. My goal right now is to kind of show you if you've mastered all these skills, how do you attack these problems straight on. So if I'm going too fast, just let me know in a comment and I'll redo the problem. 71s are going to divide out, and this is going to be 10,000. So x is 10,000. So you can see that if you're comfortable with the techniques that we've learned, we can take things that look very difficult, and they actually become pretty easy to do. Notice the math itself, the numbers are big and ugly, but the math is actually pretty simple. Okay. All right. Number 9. Number 9 says 2, so again, just translating word for word, 2 means equal x percent, what percent? So that's x out of 100, of means multiply, 16. So note that this is the same thing as saying 2 is equal to x, 16 over 100. I can take this, if this is out of 1, I can take the 100 and I can just put it under the 16 just to make it a little pretty, I guess more aesthetically pleasing on the eyes. And I'm going to multiply by 100 over 16 on both sides. And what this is going to give me is 100 over 16 times 2 equals x. Again, we're multiplying by the reciprocal because those will divide out and we're just left with 1. So now all I have to do is clean this up. Thinking about the most efficient way of doing this. Let's just do this. 2 goes into 16 8 times, so this is going to leave me with 100 over 8 is x. We could divide this straight forward, but let's just keep dividing this out. These are both divisible by 2, so this is 50 out of 4. And I don't want to do orange, dark blue. These are both, again, divisible by 2, so this gives me 25 over 2. Now, I know 24 divided by 2 is 12, so if I have one more, it's a half, so this is just 12.5 is x. Again, what I'm saying here is I'm rewriting 25 as 24 plus 1, dividing both of these by 2. 24 divided by 2 is 12, half is 0.5, so it's 12.5. And there's my answer. Okay, on to the next page. Okay, I said on to the next page, but we're actually on the same page still. Number 10. An inspector found 12 defective cameras during an inspection. If this is 0.012% of the total cameras inspected, how many cameras were inspected? Okay, so what we're saying here is he has 12 cameras that were defective, and this was 0.012%, percent is out of 100, of multiply the total. Okay, this is what the question is saying. So we have here 12 equals 0.012 over 100 x. And you could call the total t. I don't like t because it looks too much like a plus sign, but you could if you want to. And so, again, we're just going to multiply by the reciprocal. I'm not worried about the decimal and the fraction. That's not a big deal. I am a little worried about my penmanship. I apologize. It's kind of cramped. Okay, so this is going to leave me with 100 over 0.012 times 12 equals x, because these will divide out. Once more, 0.012 is going to be 12, and because there are 3 slots I have to jump, I have to put 3 zeros times 12 equals x. And then we're going to take this 10,000 and we're going to pop it to the top. So if I have 1, 2, we'll multiply by this. We're going to have 3, we have a total of 5 zeros. 1, 2, 4, 5. Over 12 times 12 is x, and the 12s divide out. Okay. We've seen this situation a couple times, so let's see if we can find a pattern here with this. So what we're saying here is when we multiply this, we have 3 zeros here, we have 2 here, and because the 12 and the 12 match up, then the answer is just going to be the number 1 and the number of zeros. Can I make that argument that I can just do that? The answer is actually, yeah, you can. That's how it's going to work out. But you got to keep in mind that this is cooked up, right? This is cooked up that this number here and this number here match up to make your, really just to show you the setup, how to solve problems that look complicated, right? If those numbers were different, you'd have to do the math that I just did there. But I do want to show you that on this one here, this is number 8, we actually did the same sort of thing. So you have 1, 2, 3, 4 zeros, right? And look what the final answer had. 1, 2, 3, 4 zeros. So could you do that? Absolutely. That does actually work. Okay, let's move on to number 11. So number 11 is what percent, you know what, actually give myself a little bit more space here. It says what percent of 46 is 458. So again, notice what I'm doing. I'm just translating word for word. What percent, so what is what I'm looking for? It's a percent, so it's out of 100, so it's x over 100. Of means multiply. 46 is 46. Is means equal. 458, 458. Just word for word translating. Just like on the previous problem, I'm going to rewrite this as 46 over 100 just to pair numbers together. I really want that to be a 6 instead of an 8 apparently. And then we're going to multiply by the reciprocal. Now here, the numbers are not pretty, so we're actually going to have to divide. We're going to have to put 458, we're going to have to play with 458 and 46. So you could actually straightforward divide that. Actually, let's just do that. Let's just straightforward and divide. Why? Because we're multiplying by 100, and that'll clean up the number pretty easily. So how many times does 46 go into 458? I don't know. So I'm going to go off to the side here. I'm going to just keep adding 46. I'm just going to keep going. I got to get to 458. So I'm going to just keep adding 46. So this is 10, 12, 13, 230. Add another 46. Keep adding. And this can be, as you can see, it does take some time to do, but the beauty of this is if I need to do this, if I need to use any other, the longer this goes, the higher the chance is that if I have to use another 46 down the road, I don't have to worry about recalculating things or guessing and checking. This is 506. I think I'm done. Let's go to 458. Went a little crazy there. Went a little bit beyond. Okay, that's okay. All right. So we have 1. This is 2. This is 3. This is 4. This is 5. This is 6. This is 7. This is 8. This is 9. This is 10, and this would be 11. Okay, so that's kind of makes sense, right? 460 would be too much, so this is 9. 9 times 46 is 415. I'm going to subtract here. Add a 0, and we're going to see how many times does that work. 46 goes into 430, 9 times still. And I'm going to pick this up in the next video.